at even and odd signals. Now let's look at the definition. The definition of an even signal is given by a continuous time signal x of t is an even signal if x of minus t is equal to x of t for all t. And the definition for odd signal is given by a continuous time signal x of t is an odd signal if x of minus t is equal to negative x of t for all t. Many signals are neither even nor odd. All signals can be decomposed into a sum of even and odd components. Okay, now let's look at this. Here in this video I'm going to show you that these proofs, even and odd signals, we will show that xc of t, this is even signal, e represents even, xc of t is equal to 1 over 2x x of t plus x of minus t is an even signal. We are going to prove that later on. And also x odd signal, this o represents odd, x of t is equal to 1 over 2 x of t minus x of t, x of minus t is an odd signal. We are going to prove this one as well. And also we are going to prove that when you decompose the signal when you decompose a signal, you can get an even signal and an odd signal. Okay, so these three we are going to show at the end. Now let's look at this one. Here we have some graph. Let's identify whether it's an even or odd. Now according to the definition of even like x minus t, if you have a negative time value and if it's equal to like if the y value is equal to the positive x of t value, that's an even. So here if you take at any points, like let's say this is something like -1, and if you pick up this point at +1, it's going to be exactly the same in the y-axis. So this is an even signal. This is even signal. And this one also exactly the same. Like let's say this is -2 and you pick a point here, and +2 you pick a point here. That is exactly the same y value. So this is also an even signal. But here if you look at this, let's say this is -2 or something, and you pick a point and you pick a point at +2, this is like the magnitude is same. Like for example, here you might get -2, but here is +2. So magnitude is same, the sign is different, negative, positive. So that's an odd signal. This is an odd signal. And here again is the same. Let's say this is -2 and this is -2, and if you look at this value here or any point, you get the same magnitude, but the signs are different. This is positive, this is negative. So that's an odd signal. And here if you look at this one, from the shape you can see this is not equal both sides. If you pick a point, like let's say this is -½ or something, you pick a point here, and if you pick a point in +½ that's like different than this, right? This is a little bit higher. And if you pick a in order to satisfy even and odd thing, it has to be like for even it has to be symmetry around y-axis, but for odd signal it is like it should be same magnitude. Like even though it's a negative sign, the same magnitude, like it can be -3, but here is +3, so it should be same magnitude, but the signs are different. So that's, it has to satisfy that condition. If the shape is different, it's not going to satisfy that. Therefore this is neither. So here we are going to see even signal, odd signal, and even odd decomposition. So first this is the one this is the one we are looking at. We wanted to prove this one, and this one. So I'm looking at first one here. This is the first one. That's given by x of t plus x of minus t, that's divided by 2. And whenever we want to see whether it's an even or odd, what we do is we put xc of minus t, like we put a negative time and see if we are getting xc of t back or minus xc of t. If we are getting xc of t back, x of t back, that's an even signal. If you are getting minus x of t, that's odd signal. So here what we did, we take a negative time and applied for it. Like here this one turned into negative, and here minus t, that's become positive plus t, so that's why we have x of t here divided by 2. And if you rearrange this one looks exactly the same as this, so that is xc of t. So this is an even signal. And if you look at this one, odd, again you take the negative time and apply in the given equation. Here if we apply this one become negative t, this one minus t, that's become plus t divided by 2. And if you compare these two, this one and this, you can rearrange to make it look like this. So if I bring this x of t to the front, this is negative x of t, so you can take the negative in front. Correct. Okay. Negative x of t. Okay, so if we take the negative x of t front, okay, wait a minute, hold on. So we want this one, and if I take the x of t to the front, okay, negative x of t, if I take the negative x of t front, this one become plus x of minus t here. So since I take the negative common right here, so when you take the common, you can put a negative here. The reason is negative plus, so that's the reason we take it as a common. This is not just belong to minus x of t, this is common. So this become x of t minus x of minus t divided by 2. And then if you compare this one with this is x naught of t and then minus x naught of t, so we are getting minus x naught of t. If we just get x of t alone, that is even. If we're getting minus in front, that's an odd signal. So we proved this one. And also we had to prove that x of t is a value that is when you add an even signal and odd signal, you have to get x of t. So here we have even signal and odd signal. We are adding these two together. From the equation we have these all for the one signal, xc of t. Actually we are adding a even signal and odd signal. X of t plus x of minus t divided by 2, and here we have x of t minus x of minus t divided by 2. If we add to these two together, here you can see these are same value and different sign, minus, and this one is plus. These two cancels, therefore x of t divided by 2, x of t divided by 2, and if you add these two together, this is going to give us x of t. So we proved that when you add an even signal and odd signal, that gives you x of t. That's it for this video, guys. I hope you guys find this video helpful. Thanks for watching. Don't forget to subscribe my channel. See you guys